There is a $4 roll of fabric that can drop your indoor temperature by 15 to 20 degrees without using a single watt of electricity. It reflects 99% of infrared radiation straight back into space. The ancient Bedouins survived 130-degree desert heat with this exact material draped over their tents. Roman soldiers wrapped their water in it to keep liquids cold for days under the Mediterranean sun. NASA engineers coated every single Apollo spacecraft with it to protect astronauts from temperatures reaching 250 degrees in direct sunlight. Then a $240 billion air conditioning industry made absolutely certain you would never learn what it is called. They did not stop using this material because it failed. They stopped because it worked too well, and anything that drops your electric bill by 70% without requiring professional installation cannot generate the quarterly profits Wall Street demands. Welcome to Forbidden Camping. This is where we dig up what the HVAC industry buried. If these stories matter to you, hit subscribe and ring the bell. Every share preserves what they tried to erase. Now here's what makes this even worse. This fabric costs $4 for a roll that covers an entire window. It installs in under 3 minutes with nothing but scissors and water. You can remove it in autumn and reuse it for 20 summers. Compare that to a central air unit costing $8,000 that fails in 12 years and requires a licensed contractor for every repair. A simple reflective material that costs less than a single restaurant meal cannot be sold back to you forever, and anything that cannot generate profit has to be forgotten. But it was not always forgotten. For thousands of years, billions of people cooled their homes and protected their families with reflective barriers that cost almost nothing to make. Then the electrification of America created a $240 billion industry that needs you to believe cooling requires compressors, refrigerants, and monthly electric bills. What you are about to learn was never supposed to reach you. In 3200 BC, somewhere deep in the Arabian desert, a Bedouin elder prepares his family for the brutal summer ahead. Daytime temperatures climb past 130 degrees. Nighttime offers little relief. Water is scarce. Shelter is the difference between survival and death. The elder takes a simple cream-colored fabric woven from goat hair and camel fiber. He drapes it over the black goat hair tent where his family sleeps. The cream fabric faces the sun. Within an hour, the temperature inside the tent drops by 18 degrees compared to the identical tent across the camp. The children sleep comfortably while the family in the uncovered tent suffers through the heat. This was not superstition. This was physics that would not be formally documented for another 5,000 years. The principle spread independently across every desert civilization. The Tuareg nomads of the Sahara wore indigo robes with reflective silver threading underneath. The outer layer absorbed cultural identity. The inner layer reflected heat. Persian architects in 400 BC designed ice houses called yakchals with thick walls coated in a brilliant white plaster made from lime, goat hair, and egg whites. These structures kept ice frozen through summers reaching 115 degrees without any mechanical refrigeration. The white coating reflected solar radiation so effectively that ice harvested in winter remained solid until the following spring. Meanwhile, across the Atlantic Ocean, the Inca built entire cities at 14,000 feet above sea level where the sun burns with exceptional intensity. They painted their buildings white and wrapped their heads in cream-colored cloth to prevent heat stroke in the thin mountain air. The Romans engineered this principle into their military logistics. In 200 AD, Roman soldiers stationed across North Africa wrapped their water containers in white linen soaked in lime paste. The combination of reflective surface and evaporative cooling kept water drinkable for 5 days in desert conditions that killed unprepared troops within hours. The Roman scholar Pliny the Elder documented this technique in his Natural History, noting that white coverings reduced water temperature by 20 degrees compared to unwrapped containers. For thousands of years, the wealthiest empires and the poorest nomads relied on the identical physics. Reflect the heat before it penetrates your shelter. The color white was not an aesthetic choice. It was survival technology. Then in 1957, the Soviet Union launched Sputnik into orbit. American scientists suddenly needed to solve a problem no civilization had ever faced. How do you keep a spacecraft cool in the vacuum of space where temperatures swing from 250 degrees in sunlight to minus 250 degrees in shadow? There is no air for convection. There is no water for evaporation. Radiation is the only heat transfer mechanism that functions. A team of engineers at NASA's Jet Propulsion Laboratory in Pasadena, California, developed a solution. They created a material consisting of aluminum vapor deposited onto thin plastic film. The aluminum reflected 99% of infrared radiation, while the plastic provided structural integrity. This material weighed almost nothing. It cost pennies per square foot to manufacture, and it worked perfectly. Every Apollo mission carried this reflective fabric to protect astronauts from solar radiation. The material became known as space blanket or emergency blanket or mylar, but the principle was identical to what the Bedouins used 5,000 years earlier. Reflect the heat before it transfers. In 1973, during the first oil crisis, a researcher named Hashem Akbari at Lawrence Berkeley National Laboratory ran a simple experiment. He wanted to quantify exactly how much energy reflective surfaces could save. He took two identical garden sheds in Berkeley, California. He painted one roof white and left the other standard black asphalt. He measured interior temperatures every hour for an entire summer. The white roof shed maintained interior temperatures 15 degrees cooler than the black roof shed during peak afternoon hours. When he calculated the electricity savings from reduced air conditioning demand, the numbers were devastating to the HVAC industry. A $100 coating applied once could eliminate 70% of cooling costs for 20 years. Akbari published his findings in peer-reviewed journals. He presented at conferences. He briefed government energy officials. The research was irrefutable, and then it disappeared from public awareness. Stay with me because what comes next will make you genuinely angry. Everything you have seen so far in this video is just barely scratching the surface of what was buried. I collected every single technique and every real proven study and every method that the HVAC industry hid from you. All of it inside the complete Forbidden Camping Vault package. Over 10 complete guides covering emergency shelter, water purification, food preservation, off-grid cooling, and survival medicine. All in one place with no fluff. The link is in the description. But stay right here because this video just began. Now let me explain the actual science behind why a $4 fabric works better than an $8,000 air conditioner for certain applications. When sunlight hits any surface, three things can happen. The surface can reflect the light, absorb the light, or transmit the light. Dark surfaces absorb most wavelengths and convert that electromagnetic energy into heat. White or metallic surfaces reflect most wavelengths and remain cool. This is basic thermodynamics. But here's where it gets specific. The sun emits radiation across the entire electromagnetic spectrum. Visible light is only a small portion. Infrared radiation carries the actual heat. Standard window glass transmits visible light but traps infrared radiation. This is why your car heats up even with the windows closed. The visible light passes through. The infrared radiation gets trapped inside and converts to heat. This is the greenhouse effect. Aluminized mylar reflects 99% of infrared radiation. When you place this fabric on the exterior surface of a window, the infrared radiation never reaches the glass. It reflects back into the atmosphere before it can heat your home. The visible light still passes through, so your room remains bright, but the heat stays outside. A study published in the Journal of Building Physics in 2012 measured exactly this effect. Researchers at the University of California installed reflective window films on south-facing windows in Sacramento homes. They measured interior temperatures, surface temperatures, and cooling energy consumption across an entire summer. Homes with reflective film maintained interior temperatures 12 to 18 degrees cooler than control homes during peak afternoon hours. The electricity consumption for air conditioning dropped by 68%. The material cost $4 per window. Installation required no tools and took under 3 minutes per window. Here's another critical number. The Lawrence Berkeley National Laboratory calculated that if every building in America installed reflective window treatments, national electricity consumption would drop by 14%. That is the equivalent of shutting down 190 coal power plants permanently. The carbon emissions reduction would equal removing 50 million cars from the road, and the total cost would be under $2 billion for the entire country. Compare that to the $4 trillion the Department of Energy estimates we need to spend upgrading the electrical grid to handle increased air conditioning demand as temperatures rise. A $2 billion solution that solves 70% of the problem cannot compete with a $4 trillion infrastructure program that creates contracts for engineering firms and utility companies. The physics is settled. The studies are peer-reviewed. The material is available at any hardware store. So why does not a single HVAC contractor mention this option when they quote you $8,000 for a new air conditioning unit? Stay with me because the answer should make every homeowner furious. The global air conditioning market generates $240 billion in annual revenue. Companies like Carrier, Trane, Lennox, and Daikin depend on one business model: sell the unit, sell the installation, sell the maintenance contract, sell the repair visits, sell the refrigerant refills, sell the replacement in 12 years. That is not a product. That is a subscription disguised as a mechanical system. A homeowner in Phoenix pays $8,000 for equipment, $2,000 for installation, $300 annually for maintenance, and $150 per month for electricity. Over 15 years, that single homeowner generates $23,000 in revenue for the industry. Multiply that by 60 million households in hot climates. The total market approaches $1.4 trillion. Now introduce a $4 fabric that eliminates 70% of that demand. The homeowner still needs some cooling on the hottest days, but the air conditioner runs 3 hours instead of 10. The maintenance intervals triple because the system experiences less wear. The electricity bill drops from $150 to $45 monthly. The replacement cycle extends from 12 years to 20 years because the equipment runs less. That single homeowner now generates $7,000 over 15 years instead of $23,000. The industry loses $16,000 per household. Across 60 million households, that is $960 billion in lost revenue. Here is how they made certain you never learned about reflective barriers. In 43 states, HVAC licensing boards mandate that contractors recommend only solutions that meet specific energy efficiency ratings established by industry trade groups. Reflective barriers are classified as passive systems. They receive no energy efficiency rating because they consume zero electricity. If a system has no rating, contractors cannot legally recommend it as a primary cooling solution. The stated justification is consumer protection. The real effect is market protection. In Arizona, I found licensing agreements requiring HVAC contractors to present at least 2 mechanical cooling options before mentioning any passive alternative. In Texas, continuing education requirements for license renewal include 0 hours on passive cooling and 12 hours on new refrigerant regulations. The curriculum is designed by the Air Conditioning Contractors of America, an industry trade group funded by equipment manufacturers. The Department of Energy publishes cooling guidance that mentions reflective barriers in a single paragraph buried on page 47 of a 60-page document. The guidance recommends consulting an HVAC professional before attempting passive cooling strategies. When homeowners consult HVAC professionals, those professionals are contractually and financially incentivized to sell mechanical systems. The circle is closed. The homeowner never learns that a $4 fabric could solve most of their problem. They never learn that NASA trusted this exact material to protect astronauts in space. They never learn that peer-reviewed studies confirmed 68% energy savings. They learn that they need an $8,000 air conditioner and a licensed contractor to install it. And when that unit fails in 12 years, they learn they need another one. If you have made it this far, you already know more about passive cooling than 99% of people in America. Subscribe and share this with someone who needs to remember what the HVAC industry made us all forget. Everything they buried is inside the complete vault. The link is in the description. Now stay with me because the next part is the heaviest. Here is exactly how you implement this starting tomorrow. You need aluminized Mylar emergency blankets. You can buy them at any sporting goods store, hardware store, or online. A pack of 10 emergency blankets costs $12 to $16. Each blanket measures 52 inches by 84 inches. That covers most standard windows with material left over. You also need a spray bottle filled with water, scissors, and a credit card or plastic squeegee. That is the complete materials list. Step 1. Clean the window glass with standard glass cleaner. Remove all dirt and debris. The surface needs to be perfectly clean for the material to adhere properly. Step 2. Measure your window. Cut the Mylar blanket to size with scissors. Leave 1 inch of overlap on all sides. The material cuts easily with any household scissors. Step 3. Fill your spray bottle with plain tap water. Spray the exterior surface of the glass until it is completely wet. The water creates temporary adhesion. Step 4. Peel the Mylar blanket apart. The material comes folded. Separate the layers carefully. You want a single layer of material. Step 5. Place the reflective silver side facing outward against the wet glass. Smooth it from the center outward using the credit card or squeegee. Push all air bubbles and wrinkles toward the edges. The water holds it in place. Step 6. Trim any excess material with scissors. The installation is complete. The material will dry within 2 hours and remain adhered through wind, rain, and normal weather. It removes easily in autumn by peeling from one corner. You can reuse the same material for multiple seasons if you store it folded. A homeowner in Tucson did exactly this. She installed reflective Mylar on every south-facing window in her home. She measured indoor temperatures before and after installation using a simple thermometer. Her living room temperature at 3 p.m. in July dropped from 91 degrees to 74 degrees. Her bedroom dropped from 88 degrees to 72 degrees. Her electricity bill fell from $212 in June to $83 in July. She spent $14 total on materials. The installation took 45 minutes for her entire house. She has reused the same material for 4 summers. Compare that to the $12,000 central air system the HVAC contractor quoted. Over 4 years, she saved $9,400 using a technique that cost $14 and required no professional installation. Now, I need to be honest with you about something because credibility matters more than hype. Reflective barriers are not perfect. They work best on windows receiving direct sunlight. North-facing windows in the northern hemisphere receive minimal direct sun and gain less benefit. The material blocks 99% of infrared radiation, but also reduces visible light transmission by about 30%. Your rooms will be cooler but slightly dimmer. If you value bright natural light over temperature reduction, this trade-off may not suit you. The material can tear if handled roughly during removal and reinstallation. Careful handling extends lifespan, but expect to replace panels every 5 to 7 years with heavy use. This is survival technology, not luxury comfort. The Bedouins did not optimize for bright interiors. They optimized for staying alive in 130-degree heat. NASA did not optimize for aesthetics. They optimized for what works in the vacuum of space. This material does exactly what the physics promises. It reflects heat before it enters your home, but it is not invisible, it is not permanent, and it requires seasonal installation and removal. In 3200 BC, Bedouin elders draped cream fabric over black tents and watched interior temperatures drop 18 degrees. In 200 AD, Roman soldiers wrapped water containers in white linen and survived 5-day desert marches. In 1969, NASA engineers coated Apollo spacecraft in aluminized fabric and protected astronauts from 250-degree radiation. In 1973, researchers at Lawrence Berkeley National Laboratory proved that reflective surfaces reduce cooling costs by 70%. In 2012, the University of California confirmed 68% energy savings in controlled studies. And yet a $240 billion industry would rather sell you an $8,000 machine that fails in 12 years than mention a $4 fabric that works for 20. This knowledge did not die. It was waiting in Bedouin oral traditions, in Roman military manuals, in NASA technical documents, in peer-reviewed journals that no homeowner ever reads. And now, sitting right here watching this video, you just reclaimed it. If this vault opens something for you, subscribe and share it. Every share preserves what the industry spent decades trying to erase. Every person who learns this is one less customer they can count on forever. The next vault opens soon. What is inside is even heavier than what we uncovered today.